This is a challenge problem solution. So we have a logarithmic inequality, and this problem is very, very similar. I mean, it's the same exact problem, just with an inequality instead of an equality, compared to the other challenge problem in this packet. So if you're watching this video from the scanned QR code, hopefully you are, I highly suggest you do the first challenge problem before this, or at least watch that video, because I'm going to assume that you know that solution because it's kind of required to understand how we're going to do this one. Um, and the takeaway from that video is that we need to use U substitution. So I'm going to get started on this problem. Um, First step is to move 2 in front of the logarithm. And then from this point, we can notice that we have a sort of quadratic. I can take u equal the natural log. It's ugly. U equals the natural log of t. Now this gets me 2u is less than or equal to u squared, and I can subtract the 2u, and then I can factor 2 minus u. Okay, now at this point we have two solutions, right? We get u equals 0 and u equals 2, but we need to make a sign diagram, right, because we're solving an inequality. And let me move this because I'm kind of trailing off a little bit. Okay, in my sign diagram, we are going to have 0 and 2 as my points, and those both come from positive linear terms. And so my sign diagram looks like positive, negative, positive. And in the context of the equation, we want to know when these intervals are positive. And so the intervals we end up getting is negative infinity to 0, and that's included, union 2 to infinity. Okay, now I'm going to take this and move this back up to the center. And what's really, the challenging thing about this is these intervals are, in a sense, correct, but they're still taken under the assumption of u substitution. So we actually need to resubstitute our natural log of t, but within the endpoints of these intervals. And I'll do each one in a different color just so it's kind of easier to keep track of. But let's go through each one. So instead of negative infinity, what I need to do, because negative infinity is what u equals, and if u equals negative infinity, well, I need to know when does the natural log of t equal negative infinity. Now, of course, there actually isn't a point on the natural log of t where it equals negative infinity, but the intuition you need to know is that on the graph of natural log of t, there is an asymptote that goes down to negative infinity, and that asymptote's occurring at 0. So the natural log of 0 is going to approach negative infinity, and because this is a endpoint with a parenthesis, we don't really need, like, we can kind of, it looks like shady math, but trust me, it works out. Um, we are allowed to say that this interval becomes 0, because the natural log of 0 will go to negative infinity. Okay, so let's keep going. I'll pick a new color this time. Next, we need to ask about 0. So again, 0 is the value of u, so I have to ask when does the natural log of t equals 0. Well, if I just kind of take e of both sides, I get t equals e of 0, and then any power, or any exponent raised to a 0 is 1, so t equals 1 in this case, and that leads to a 1 on this interval, so I can close that off. Next we have the union, and we open up another interval. Now we're asking about, well, what if u equals 2? So I know my value of u is 2, so I can say the natural log of t equals 2. Take e to both sides. I say that t equals e squared. I can't really simplify this any further. My headset turned off. Sorry about that. I can't simplify that any further. That's just what we're going to get. So t equals e squared, and that can get put right into here, just as e squared. And then I kind of want to scroll to the right a bit so I'm not in the way of my face cam. But next we have another comma, and then we again are going to do another analysis on the infinity. So I'm asking, well, if infinity is u, then the natural log of what equals infinity? And again, It doesn't really equal infinity, but we can look at that same picture of the natural log, and as t grows and grows and grows, the natural log is going to tend to infinity. So we want t to head in the direction of infinity as well. And again, I have a parenthesis. I'm not including infinity because infinity isn't a number, but I am justified in saying that infinity is my next endpoint. And in my very colorful fashion, I think I did a very nice job here. This is the final solution. So we had to use u substitution to actually generate those intervals, but then we resubstituted those endpoints to get this as a final answer, which is indeed correct. I have the answer pulled up because this is a tough one. Wanted to make sure I got it correct, but that is how you solve this quite difficult logarithmic inequality.